Hey there, CJ Math students, and welcome to Homework 3.3. It's called Number Fluency 1. These are very much similar to Ames Webs in that they will pop up throughout the year. It's a good way for you to show me that you are fluent with rational numbers and can express them in a whole bunch of different ways. It's all about equivalency, right? So for instance, I will give you one number, and you have to give me all the other ways you can represent that number and have it still be equal. So for instance, 5 over 4, how can I write that as a mixed number? Well, I can say bottom into top. I don't need decimal 0, that's only with decimals. So 4 into 5, it goes in there one time with 1 left over. And so what does that give me? That gives me 1 and 1/4. And then I put my answer on my answer line, 1 and 1/4. Right? Now, give me another fraction. So I look back at this fraction and I say, okay, let's just take 5/4 and let's multiply it. I can multiply it by 2, I can multiply it by 4, 5, 6, whatever I want, right? But by multiplying it by a number, let's just do 2 today, we are in essence basically showing that, hey, 10 over 6 is equivalent to 5 over 4. I could simplify that and I would get 5/4. Or 10 over 6, I would get 1 and 1/4. Right? Actually, I'd get 1 and 4/6. Which would simplify, sorry, that should be an 8, my fault. I'd get 1 and 2/8, and that would simplify down to 1 and 1/4. So 10 over 8 is an example. I could do 5/4. You don't have to write this down. 5/4 times 3, right? I could get 15 over 12. Whatever you want to do. Pick an easy number, okay? All right, decimal. So basically, I want you to take this mixed number and give me a decimal. Or you could literally take that fraction and give me a decimal, however you want to do it. I think it's easy to do the mixed number to decimal because, look, there's your 1, and 1/4 is your 0.25. Now, Mr. Mason, what if I didn't know my fourths? How would I figure that out? Well, I do 4 into 1, decimal, 0. Eventually, I'm going to have to do 2 zeros here, but 4 goes in there 2 times. It gives me 8 with 2 left over. Bring down another 0. 4 goes into 20 5 times, and I got nothing left over. That's how I got 0.25, so 1.25. Rewind that, watch that again if you need to. What's another decimal? Well, here's my original decimal. What's another decimal that's equal to that? Same thing. I'm not going to multiply by anything here. I'm just going to add a 0. 1.250 or 1.2500 or 1.250000, right? They're all equivalent. So 1.250. Percent. What I'm going to do, move 2 times right. Okay, that's all you're going to do in every single time this comes. So you got 1.25. You're going to say, all right, I got my decimal. Start from my decimal and go once, twice, put a nice little arrow on it. And so what does that give me? That gives me 125%. 125%. Now a picture. Some of you may say, well, how do I draw a picture of 125%? You don't have to think of the 125%. You can literally think of the mixed number, 1 and 1/4. Well, what does that mean? Okay, I got one hole, so I can shade that whole thing in roughly, right? Doesn't have to be beautiful. And 1/4. What does that mean? I need to divide this circle up into fourths. 1, 2, 3, 4. And I just need to shade in one of them. So that's what 1 and 1/4 looks like. All right, now I'm going to try and move this here. Hopefully it works. Good. Now here's the only part that's not actually equivalent. I want you to take half of the number and I want you to take double. And I want you to use the fraction to do it. It's much easier to do it than to do it with the decimal. Or you can, but I just want us to practice working with fractions. So we've got take half. So I want to take the original 5/4 and I want to take half of it. How do I divide fractions? You shouldn't be freaking out because I'm going to help you right now, but also you have a reference sheet that literally tells you how to do this. 5/4 times, right? 1 over 2 because you flip the fraction. What do we get out of that? We get 5 out of 8. So we put down 5/8. Now, everything's nice and neat so far, so make sure your paper is nice and neat. If not, go back, erase, rewrite it. Take pride in your work. So how do I double this fraction then? I do 5/4 times 2 over 1. And before I double it and just multiply straight across, I should go ahead and take, can I cross cancel? Sure can. Divide by 2, that becomes a 1. Divide by 2, that becomes a 2. What do I get? I get 5 over 2. Now, am I okay for you writing an improper fraction down? What do you think? For this, I'm going to say I actually am okay for today. In the future, I think I'm going to have you change that into a mixed number. So for now, you can put down 5 over 2. If you're fancy, you could have put down 2 and 1/2 because that's what 5 over 2 is, a mixed number. So if you just want to put 5 over 2, not to confuse yourself for right now, that's fine. All right, I'm going to do B as well. Basically, I'm going to do this whole front side, and then you're going to do the back side. It's the same thing, but with just different numbers. All right, so this time I start you off with a decimal. And I say, okay, give me everything that's equivalent to this decimal, which is going to be a little bit difficult. But hopefully you realize, okay, there's a couple things I can realize right off the bat. This 0.3333, that should look familiar. That's 1/3. And that 4, oh, that should look familiar. That's just 4. 4 and 1/3. Oh, look at that. I've got my mixed number, 4 and 1/3. But let's show Mr. Mason some work. So 4.333 repeated. And you can say, hey, I know this is 1/3. That's how I got that there. And I know the 4 goes there. So how do I turn it into a fraction? You're like, Mr. Mason, it's already a fraction. Yeah, but let's turn it into an improper fraction. All right, so 4 and 1/3, we do 4 times 3, which is 12. 1 plus 12 gives us 13 over 3. Okay, now how do I do another fraction? I take 13 over 3. See, I'm jumping around all over the place, but all this stuff is equivalent. That's the beautiful thing about this. And I can pick whatever number I want. I usually just pick the easiest number, 2 times 2 times 2. What's the purpose of this? The purpose of this column right here is to say, hey, you can have fractions that actually are equivalent to this that don't look like this, right? Because if you simplified this, you would get this and get that. Okay, it's still equal, even though they look way different. You say, wait, you multiply by 2, it should be bigger. No, because I can simplify this down. These are still equivalent fractions, right? I increase the numerator, but I also increase the denominator by the same thing. So the fraction stays the same part of a whole, right? Another decimal. How am I going to do another decimal to 4.333 repeated? Well, here I just added a 0. But if I add a 0 here, it's no longer repeated. So what do I do instead? I just add another 3. 4.3333 repeated. Or I could add a third 3, or a fourth 3, or a fifth 3. I could add as many 3s as I could fit in there, right? But that's my answer to that one. That's going to be a unique one when it's repeated like that. Other than that, you just tack on a 0, and that's another decimal that's equivalent to the decimal you have. What about a percent? Again, it just says move 2 times right, so take that 4.333 that you have repeated, and go ahead, start from your decimal point, move once, move twice, nice little arrow there, and you got, 433.3 repeated percent. And that's your answer, 433.3 repeated percent. Now, how do I get that picture from that? You don't have to worry about that. You can literally go back to 4 and 1/3, right? So you've got 4 circles that will all be shaded in, roughly, right? It doesn't have to be perfect. So there's 1 hole, 2 holes, here's 3 holes, here's 4 holes, and now I need 1/3. So how did I divide this up? I divide it up into third. Now I can do it by columns, whatever I want. This is usually how you do third, kind of like a Mercedes sign, right? And that was kind of rough, but a third, right? Pizza. And only 1/3 of it is shaded. All right, gonna move this over. And remember, in this column, we are going to take half, and I want you to use the fraction. So use the fraction, go all the way back. You got the fraction 13 over 3, 13 over 3. It wouldn't make sense to use the mixed number because you'd have to change that to an improper fraction anyway. And divide it by 2 over 1. It's key to write that first step, and it's key to write this, oh, I know I need to flip it. All right, so we have 13 over 3 times 1 over 2, and like I said, I'm okay with improper fractions for the start of this. It's 13 times 1 is 13, 3 times 2 is 6. So 13 over 6 is your answer there. If you were fancy, you would say that would be 2 and 1/6, right? Taking half of that. And it actually makes sense if you go back and look at your mixed number here. Half of 4 is 2, half of 1/3 is actually 1/6. So that's why that makes sense. 13 over 6. Now I want you to double it. 13 over 3 times 2 over 1. So no flipping here. We also don't have any cross canceling that we can do. So literally just multiply straight across. What do we get? We get 26 over 3. I'm okay with you putting that down for right now. 26 over 3 is basically, if you did 26 goes into 3, 23 goes into 26 8 times, which is 24 with 2 left over, 8 2/3. That's basically 4 1/3 multiplied by 2. right? And the last column. I know this video is long, but trust me, you're going to want to pay attention because the back side will be super easy if you can get the front side. So I gave you a mixed number. What would be the easiest thing to start right off the bat with the mixed number? I'd say turn it to the improper fraction, 4 3/8. Say boom, times 8. That gives you 32. So you have 35 over 8. Wonderful. Give me another fraction? Fine. 35 over 8. We'll just multiply that by 2. And I get 70 over 16. Okay, done. 70 over 16. All right, give me a decimal. Ugh, I don't know how to do a decimal of 4 3/8. I could divide. I could do that, but I could also say, okay, I know it's going to be 4 point something, and then I could say, oh, I've got a reference sheet, and I could go look up what 3/8 is, and I bet you if you did, you get something like 375, and that's exactly what it is, 4.375. So use that reference sheet. What's another decimal? So if I have 4.375, all I have to do is tack on a 0. So 4.375 is the same thing as 4.3750. All right, what's the percent? All I got to do is write down my decimal. Oh, sorry about that. And move 2 times to the right. So once, twice, draw the arrow. I'm not happy with that. I'm going to erase it. I tell you guys to write neat. I'm going to try and write neat. 4.375. Move once, move twice, draw the arrow. Okay, so it's 437.5%. I could worry about saying, well, I could draw in the 4 holes, but how am I going to get the 37.5%? No, just go back to your mixed number. 4 holes, 1 hole, 2 holes, 3 holes, 4 holes. Now, I'm not quite sure how to draw ace, but I'll do my best. I'll draw a 4th, 1/4, right? 1/4, 2/4, 3/4. And I'll just do it again. Right, and there you go. I got it into eighths, and I just want to color in 3 of them. So 1, 2, and 3. 3/8, 4 3/8. And finally, I just need you to double it. So don't double 4 3/8. Take the improper fraction that you made out of it. 35, sorry, this is taking half. 35 over 8 divided by 2 over 1. Remember, you need to flip. Don't cross cancel just yet. Flip first. 35 over 8 times 1 over 2. And again, I'm okay with you leaving it as improper, so 35 over 16, because you multiply straight across. When you multiply fractions, you don't got to worry about common denominators or anything like that. And then we want to double it. So 35 over 8 times 2 over 1. We can cross cancel here. There's no flipping involved, so cross cancel. Divide by 2, that's a 1. Divide by 2, that's a 4. 35 times 1 is 35. 4 times 1 is 4, so 35 over 4. Now, you need to do one more thing before you can flip over to the back, and that's place letters A, B, and C on the number line. So let me move this guy over here. So let me just recall. A is 5/4. So where would 5/4 go? Now, you might be freaking out. It's like, I don't know where 5/4 is, but look at the other numbers. You have 1.25, right? You know where 1.25 is. Well, here's 1, and 1.5 would be halfway between there, so 1.25 is halfway between here and here. So here's 1.25, otherwise known as 5/4. There's A, all right? 4.33333 repeated, right? Or 4 1/3. So if I have 4, and just like ST Math, if I divide it up into thirds, 1/3, 2/3, 3/3, right? Maybe a little bit more than that, 1/3, 2/3, 3/3. So 4.333 repeated is going to be right there. So that's B. And C, 4 3/8. Well, where's 4 3/8 going to go? Well, don't look at 4 3/8. Look at 4.375. Now, 4.375 is a little bit bigger than 4.333, like literally just a hair bigger. Some of you may say, well, but 4.333 goes on forever. Yeah, but if you line up the decimals, this 7 in the hundredths place is bigger than that 3 in the hundredths place. So C is just a little bit bigger than A. Very close, but just a little bit bigger. So look at the back, guys. The back is literally the exact same thing as the front. I've just given you different numbers. So use your reference sheets. I've given you 7/4. I've given you 2.66666 repeated. Hopefully you realize that's 2 2/3. And I've given you 3 1/8. Use your reference sheet for the eighths. Should be very straightforward. Call me if you have questions. We need to get good at this, guys. We need to practice our number fluency.